Hey guys, we're going to do a real quick rundown. What is a mid-segment? This is our fifth special segment, and there's a few things that it must do. One, it must connect two midpoints of a triangle. So if you have a triangle and you draw it, and you have a midpoint on this side and a midpoint of this side, all a mid-segment does is connect those 2 points together. So that line AB is a mid-segment. And two things happen when you have a mid-segment. It ends up being exactly half the size of its base. So like CD here, I would call it its base. It's the one that it goes the same direction. It is half the size. So if this is 10, then the base here would be 20. And the second thing that must occur is that it must be parallel to its base. And so we know that these two lines will be parallel. That means we know stuff about angles, right? If this angle is 50 degrees, this corresponding angle would be 50 degrees. Those are the things that we know. If we go look in GeoGebra real quick, a few things here. First, it connects two midpoints. So I'm going to find some midpoints. So I have triangle ABC with midpoints D, E, and F. If I draw a segment connecting D to E, we know a couple things. We know that DE is exactly half its base, right? 2.71 is exactly half of 5.42. I also want you to notice here that B to F and F to C all equal that number. There are three pieces here that are all the same size. They're all half of BC. And this happens when you connect two midpoints. Now I could connect D to F. What would D to F be half of? D to F would be exactly half of the side AC. Now this program rounds a little bit, so it's 6.44 and 12.87. That's because it's rounding to the nearest hundredth, but I can assure you it's exactly half. And we would know that from A to C, it's 6.44, and C, I mean, if you look at this, like, right, these midpoints are even 6.44. So it's a rounding issue is why it doesn't look like it's half, but it's exactly half. And then if I connect the last mid-segment, E to F, same situation, E to F would be exactly half of A to B. And that checks out pretty nicely. So the mid-segment is exactly half its base, and it is parallel to its base. And no matter what I do, right, like this, these numbers continue to stay true, right? They continue to be half, 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 half. That black triangle is called a mid-segment triangle. When you do this, what does it look like? It looks like our friend, or looks like our Triforce from the game Zelda, right? Do 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 do. Yeah. So what are some things you can do with this? Well, let's say you know that you have these mid-segments. How do I know they're mid-segments? Because these are marked as equal. And so I know that we're dealing with a midpoint, right? These two parts are equal, so this is a midpoint. These two parts are equal, so this is a midpoint. These two parts are equal, so this is a midpoint. So when you connect midpoints, you're creating a mid-segment. And we know that they're parallel to their base. So like this 50, these two lines would have to be parallel because of the mid-segment property, so this would have to be 50. If you go the other direction, this side would have to be parallel to this one, so this would have to be 50 degrees as well. If I go up to the 60 degree, right, this side has to be parallel to this side, so this would be 60. And we already said, like, this would be parallel to this, so this would be 60. And then if I work inside the individual triangles, if those are 50 and 60, this would be 70, 70, 70. And we can even get the angles of the middle one. Like these three angles have to add up to 180. That's one way we could do it. Or I could do zigzag with this 50. That's another way I could do it. It's going to check out either way. So this would be 50. I could zigzag the 60 to here, and I could zigzag the 70 to here. We know alternate interior angles have to be equal. So this would be 60, this would be 70. Or you could use this rule that those three angles have to add up to 180. So parallel lines give us angles. Also, if we have a situation like this, we know that the mid-segment is exactly half its base. That means it would take two mid-segments to equal its base. So 4x plus 14 would equal 8x minus 2. So 4x would equal 16, x equals 4. Plug it in and check it out. This would be 8 plus 7. So this is 15. Plug in 4. This would be 34 minus 2. So this would be 32. 32. Wait a second. 8 times 4 is 32. I was right the first time. 32 minus 2 would equal 30, and 15 is exactly half of 30. Boom. So let's make sure that we're very clear on two things, or on a couple things. What if I knew that I have a line that was parallel? Like, if it's parallel, does it have to be a midsegment? Well, no, it could be parallel way down here. It could be parallel way up here. Those could all be parallel to this side. So being just parallel is not good enough to be a midsegment. What if you're exactly half? Well, could I have a line, like if this is 10, could this technically be 5 and not be parallel? Yeah. So you can be half and not be parallel. You can be parallel and not be half. But if you are both things, if it is parallel and it is exactly half, like this is 10 and this is 20, then you would know that it's a midsegment. So if I look at this definition, both of these have to happen to be a midsegment. Now, what if this happens? What if you know it connects two midpoints? Well, then yes, that's automatically a midsegment. So the definition causes both of these to occur. And if both of these occur, then you know you have midpoints. But there's a short lesson on midsegments. Hopefully you understood that. I'll see you next time.